Peter, can you share your
I will
screen?
share my screen, and I want to thank Markus for doing a perfect setup for what I wanted to show today.
Great.
Because what he's been showing has actually been near and dear to our hearts for quite a long time. And so in the last period of time during COVID, we've really consolidated all of the code that we had around atom probe analysis. And so now we are able to. Can you all see my screen?
Yeah, it's looking good.
Yeah. Okay.
Yeah, great.
So we've put together an entire atom probe analysis package that gives you all the tools essentially that you need to analyze your data from beginning to end in an interoperable way. So I agree very much that we should be able to at any point jump from tool A to tool B without any problems. And we sort of give you the basic analysis tools that you need to cover everything that is sort of the basic analysis things. And we cover it in a way that allows you to be very interoperable and that allow you to create what I call institutional knowledge. Yeah? So you're starting to build up certain what we call ground truths, and based on those ground truths, you work your way up. Our most basic ground truths are actually an isotope table. So you can see we've got a table of isotopic abundances and weights and so on and so forth, and a color scheme. Yeah? So you give a color scheme out for certain ions, and you tell it what kind of color you want it to be. Then you can go to ranging. So you can do all of the ranging by first defining ions and then defining ranges on top of them. And we give you the full ability to search for ions in your code. So you can see here as a quick example, I've got a superalloy mass spectrum, and I can go ion find, and it will pop up with the mass spectrum. I can mark a peak, and it will tell me, okay, this is most likely chromium-52, but I could try out if it's something else. But I guess chromium-52 was a pretty good guess by our programs, and I can go okay, and then just say, okay, add a range in mass spectrum number 2. Sorry, because I've got range add. Sorry, range add. And then you can just go and mark your mass spectrum window, and it will show you, okay, this is chromium-52 2+, and you can assign all of that in your to your pos variable, and then your pos variable will show you for each hit what the XYZ is, what mass to charge, what ion it is, what charge state, what atom, what isotope, and what ion complexity. And if you have more information, can give you a whole lot more, but this is just for a regular POS file. And then you can put your analysis on top of all of that. And we offer you quite a lot of different analysis tools, most importantly, advanced concentration analysis. So you can bin your data in n dimensions based on whatever property you like. And then you can run what we call concentration kernels on your data and calculate things like, in this case, a 2D concentration map. And you can use all of the information that you have in your mass spectrum about ions, about ranges, and so on and so forth, to do that analysis. And it's all at any point accessible to you. And it's not just accessible to you if you want to use MATLAB, but you can also go outside of MATLAB and export it. And just like the group at NPIE, or at least like Markus, we're using HDF5, and we've put quite some effort into creating HDF5 definitions in order for your data to be very shareable. I have to say, in this case, our starting point was not atom probe tomography, but we have big collaborative research centers that require us to have data and metadata together. And atom probe tomography is just one very small aspect of that. There's SEM, there is TEM, there is EBSD, there is particle analysis, there's electrophoresis, and so on and so forth. And so we've come up with metadata definition files like this file here, where we have path and where we define the naming of whatever metadata we have and of whatever data we have that we can then inject into our HDF5 file. We can do that for Atom Probe data quite easily by now. And you can see you get a file like this, which you can, for example, open with an HDF5 file viewer. And it will show you what information is in the file and what you can do with it. So you only need the file. You need no explanation from us, okay? If someone gives you the HDF5 file, you need no information. What's in there, you can find all of that out for yourself. In this case, we've defined a reconstruction. We've defined images of the sample. So I can, for example, open the image of the sample here. Sorry, I'll just go and show the data, and you can see it's an SEM image, right? That is saved together with the Atom Probe data. This really allows you to build up highly capable data science analysis for Atom Probe tomography, because we've made everything as scriptable as possible for you to be able to do your analysis not on one data set, but on 1,000 data sets or 10,000 data sets. Okay, and yeah, that's it from me for today, because I've already talked for 6 minutes.
Peter, great. Really supporting this. Should discuss more about this at some point. Are there questions to Peter's talk?
Oh, by the way, the code is all available to anyone that wants to use it under I'll give the GitHub link. We will publish something about it, but if you're interested already, you can go on it. It comes with all kinds of tutorials and MATLAB live scripts that just explain everything and how to use it. My students can by now use it by themselves, so yeah.
Great. There are no questions at the moment in the chat. There's one popping up from Philip. Does your code have any overlap solving built in at the moment?
Not the code that we've added to the GitHub, but so the purpose of explicitly defining isotopes and everything in the mass spectrum, so defining all the ions in the mass spectrum, is actually explicitly made to deal with overlaps, yes. But the what we call concentration kernel for overlap solving is not yet pushed into the GitHub Atom Probe toolbox, but it will be in the coming months. Yeah. And the good thing is you can use that concentration kernel for any dimensionality. You can use it for the entire data set, for a proxygram, for a 2D map, for voxelization, for whatever you like.
Okay, this seems to answer the question. Further thoughts and ideas and questions to Peter? No reason to be shy.
And also we also have very extensive code to do machine calibration, because we do have 2 Atom probes that we've built ourselves, apart from the commercial one that we operate. But this will only be included in the next release, probably early next year, because we sort of, it's not as user-friendly as the other scripts in there.
Do you have any plans, Peter, to do any kind of anything for helping people get started with this?
So right now there are already tutorials in the form of MATLAB live scripts in there. Let me just show it to you. I can show you one what that looks like. So this is where did I put it? Where did it go? Oh yeah, this is a MATLAB live script. Yeah, and this live script, for example, explains how to create an isosurface. Yeah, with either just programmatically or using the isosurface widget app that we supply. Yeah. But my student, Martina Heller, is currently recording video tutorials that will be available hopefully not too long in the future. But it should be possible for people to get started based on the MATLAB live scripts already.
That's great. Thank you very much.
The point is, this code is not meant to be a feel-happy graphical user interface. It's meant for people to be able to do analysis on a lot of data in a short amount of time. Again, we want to see not analysis on one data set or two data sets. We want to see analysis on 1,000 data sets so that we can see trends. You know, what does the background in Atom Probe look like depending on the pressure in the measurement chamber? Yeah, things like that. But also all your standard analysis is included as well. This is 10 years of me coding that's included in there.
Yeah, no, I know the feeling very much, and I'd say in my own work, the transition from looking at doing analysis on a single file at a time to being able to run a bunch of stuff all at once is definitely very empowering. So thank you very much for that, Peter.